Question 1. The gravitational field strength at the surface of a planet X is 90 newtons per kilogram. In this question, the field strength may be considered to be uniform. Calculate the energy needed to lift a mass of 15 kilograms to a height of 10 meters above the surface of planet X. So we're just using the idea that the energy transferred is equal to mg times the change in height. So it's work done is force times distance. So here, a mass of 15, the gravitational field strength is 19, and a height of 10 meters. Right, find a calculator. 15 times 19 times 10. So that's 2850. Because this is a physics question, we should think about significant figures, which look to be 2. So 2900 joules. Calculate the gravitational potential difference between the surface of X and a point 10 meters above the surface. So we know that the gravitational potential is the energy per unit mass. And so the difference in potential should just be equal to the difference in energy divided by the mass. In other words, in this particular case, it should just be g times the change in height. So we could take our previous answer and divide it by 15, or we could start again and just do 19 times 10, which tells us it's 190 joules per kilogram. Or if we're writing it correctly, joules per kilogram written like this. So this tells us the energy per kilogram to move between 2 points. Part C, comment on whether the value you calculated in A would be too high or too low if the radial nature of the field were considered. So if we consider that, we'd expect the value of G would decrease as the height increased. Therefore, the energy that we calculated is correct for the surface, but as soon as we go up above the surface, the value we've calculated is too high. So value calculated is too high.